Hello everyone, welcome to my YouTube channel School of Chemistry. So today we are going to study about heat capacity, specific heat capacity, specific heat capacity and molar heat capacity. Molar heat capacity. So these three types of heat capacity we are going to study, that is heat capacity, specific heat capacity and molar heat capacity. Let us first start with the heat capacity. What is heat capacity? So heat capacity can be defined as the amount of heat required to raise the temperature of a system by 1 degree Celsius. So it is mainly represented by C, capital C. So it is the heat capacity which is required to raise the temperature of system by 1 degree Celsius. So we can write down C is equal to heat supplied to a system, we represented with the symbol Q, and the change in temperature which is there due to the heat supplied to it, that is represented by delta T. So we can write down the formula for heat capacity as Q upon delta T. Second thing is the specific heat capacity. Now it is defined as specific heat capacity. It is defined as the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So now over here we are specifying the amount of substance in specific heat capacity, that is 1 gram of substance by 1 degree Celsius. So it is represented by the symbol Cs, and that can be written as Q upon delta T into mass of that substance. Okay, whatever we are taking. Third heat capacity is the molar heat capacity. It is defined as the amount of heat required to raise the temperature of 1 mole of a substance by 1 degree Celsius. So it is represented by the symbol Cm and can be given as Q upon delta T into small m, and we can put capital M over here, and capital M represents the atomic mass or molar mass of that substance, and M is the amount of substance. Let us understand the difference between these three heat capacity by taking an example. So let us consider an example. For example, we supplied 5.4 joule of energy or heat, you can say, to 3 gram of aluminium, 3 gram of aluminium metal, to change its temperature from 298 Kelvin to 300 Kelvin. So let us first figure out the heat capacity of aluminium. Heat capacity of aluminium, that will be equal to the heat supplied. So heat supplied to the system is 5.4 joule. This is the amount of heat supply, and the change in temperature, that is T2. T2 is the final temperature, 300 minus 298. So it comes out to be 5.4 divided by 2. Okay, and if we divide this 5.4 by 2, it comes out to be 2.7 joule per Kelvin. Okay, so this is the heat capacity for aluminium, 2.5 joule per Kelvin. Next, we are going to calculate specific heat capacity for this. Specific heat capacity of aluminium, that can be given as 5.4, which is the amount of the heat supplied, divided by change in temperature with delta T, that is 2, into amount which we are taking over is the 3 gram, so into 3, so it comes out to be 0.9 joule per Kelvin per gram. So this is the specific heat capacity for aluminium, and let us calculate the molar heat capacity. Molar heat capacity of aluminium can be given as amount of heat supplied, which is 5.4, amount upon change in temperature, that is of 2 Kelvin, into amount which we have taken, that is 3 gram, and that should be divided by its atomic mass, that is 27. So that goes up, so we multiply 27 up over here, and after calculations, so 2 we divide it over here, it comes out to be 2.739 27, so 9 multiplied with 2.7, it comes out to be 24.3 joule per mole per Kelvin. So this is the molar heat capacity of aluminium. Now our molar heat capacity further are of two types, that is molar heat capacity, which is measured at constant volume, and molar heat capacity measured at constant pressure. As we know that heat supplied to a system is not a state function, it's a path function. Similarly, the molar heat capacity is also a path function, that is it also depends on the path, specified path which it will be following in order to, you can say, change the temperature of any system or surroundings. So that's why it is further classified into two types, that molar heat capacity, which is measured at constant volume, and the second one is a molar heat capacity at constant pressure. So let me write down for you people types of molar heat capacity. So they are of two types. A molar heat capacity at constant volume, which is represented with CV, and the second one is molar heat capacity at constant pressure, and it is represented by CQ. So that was all about the heat capacity, specific heat capacity, and the molar heat capacity. So in my coming video, next video, we will be driving a relation between these two types of molar heat capacity, that is CP and CV. So hope my videos are helping you in your studies, and for more interesting videos, please like and subscribe to my YouTube channel, School of Chemistry. Thank you.